you lose your socks in sleep?
Yeah, I use it in the washing machine. I literally put 2 socks in there and 1 sock comes out. That's cool.
I actually lose my socks when I'm sleeping. So they call me Naomi One Sock. Yes, my dad.
All right. I probably should have warned you earlier, but just so you know, I'm going to be observed this Thursday by an assistant principal.
Oh, shit.
Yeah, it's happening to a lot of teachers, and it's not a big deal. It's not a hostile thing. Teachers get observed every certain number of years, and it's my year to be observed. Yeah, you can play there's no reason for you to stress about it. I'm hoping that class will be pretty much normal. But I would appreciate it if next Thursday you guys can be kind of on your A game a little bit. One thing that's a really big whoop is how quickly it takes the class to get started. So on a good day, while I'm taking attendance, you would usually copy stuff from the board, and then as soon as I'm done with my attendance, you'd be done copying, and that's the way I'm trying to run things on Thursday. Just so you know to anticipate that.
So Dan not here.
So there's Thursday and the day after tomorrow.
Oh, okay.
What?
I'm not here.
Thank you. You're also on.
Yeah.
Wait, how can they tell you?
Because there's different sorts of observations. There's the drop-in kind, where they're like, hey, I'm just going to check out your class for 10 minutes. And those happen all the time, and those are not a big deal. They have a right to be in the class. You don't have an expectation of privacy from them, and they have a special responsibility to monitor our work. So they drop in and see classes all the time. A separate deal is these observations for our employee file, like that's when they evaluate us. And those are on like a very carefully regulated schedule, and there's like a procedure that the school board has worked out with the union, and so they have to tell us, and we meet in advance and say like, hey, I want you to evaluate my good looks or something, and so when they sit here, they'll give us guided feedback. Okay. So, so today I want to back up a smidgen. I'm sorry, but we actually skipped some stuff. We're on 9.3 today, and 9.4 will be stamped by Naomi. Just leave it on a corner of your desk, and please don't distract her while she's stamping. Also, don't talk to her, and don't make her talk to you, because she'll give you cooties. And I want to, step back a little bit, review a couple things from yesterday, and go from there. Tell me if you recognize this thing, the Keeling curve about the Earth breathing. When does CO2 level drop? Southern summer or northern summer? Southern summer. Southern summer, very good. And back to me, please. How much of Earth's incoming solar radiation is reflected by the Earth back out to space as Earthlight? 30%, that's right. So here it is, 70% is absorbed by some part of the Earth system. The remaining 30% are reflected out to space. incoming versus outgoing is in this diagram. We already talked about this. The greenhouse effect is the little arrow on the right. The amount of heat that we keep. And I'd like to do a highly scientific demonstration for you. Did I already do my wobble yesterday? Yeah. You guys got the wobble thing? Yeah. Those are the greenhouse gases. Here they are on the list. We'll talk about them later today. Remember that not all gases wobble. Nitrogen gas, oxygen gas, no wobble. They're stable. They're not going anywhere. So did we talk about the science of climate change yesterday? Talk about this guy? No. Oh, well then. This is the part that I skipped, and I'm sorry that I skipped it, but I'd like to have a little conversation today about the science of climate change. Because I'm sure you've heard there is this so-called debate about climate. I hope that none of you will take this personally, but I have to tell you that there is no debate about climate change. What do you mean? There is no debate about climate change. And anytime that somebody wants to debate climate change with you, I want to give you the tools to have that conversation. And you should be gentle because someone clearly doesn't understand what they're talking about. Just saying. Okay, so watch. This guy that you see up there was the first person to discuss climate as a changing system. The concept of climate changing for natural causes goes back to this dude. And you can probably tell that it's been a long time because you'll notice he wasn't photographed. That's a wood etching, a wood engraving. Well, we also know the date. Yeah. So photo emulsion didn't exist yet. At this time, we did not have what we call the germ theory. Germ theory is the idea that specialized single cells can start life. We didn't have microscopy. Oh, I got your email. Were there stragglers that haven't been answered in your case? Or was it about the Unit 7 exam?
No, there's stragglers, but just one from where I got it.
Stragglers should be before the end of the week. It might be as early as tonight. But I still have to finish with the test. And I finally have settled on the curves. So now I'll be turning on the exam. I'll probably be stragglers at the same time. Today's like a hectic day, so I have a meeting tomorrow to talk about that observation on Thursday. So like right now I'm kind of just thinking about that. Alright. In 1824, if you were going to get surgery, your anesthetic was whiskey. In 1824, if you were going to get surgery, the surgeon would not wash his hands. In 1824, we did not have most of modern chemistry. We didn't know how to make fertilizer. We didn't know how to achieve a balanced diet. I believe we could not repair cavities in 1824, or if we could, it was probably at the very beginning. But I reckon that in 1824, yeah, let's pull them out. This was a very early time in science. We did not have the theory of glaciers. We did not have an evolutionary theory. We did not know about genetics, about inheritance, about sperm and egg. Well, the only scientists were educated by the church. This was a long time ago, and we already knew about climate change. As a matter of fact, we did our first experiment. Try not to focus on the beard. Try not to focus on the beard. Don't focus on the beard. Let's move on from the beard. Okay, so if he's instead of a giant nut. You got a sundial. Look. All right. This guy was the first person to actually do tests on greenhouse gases. He figured out which gases in our atmosphere cause global warming. And he did that in 1858, a little bit before this photograph was taken, because you understand there were no photographs in 1858. He was a famous scientist for a bunch of other reasons. There's a really beautiful creek and meadow named after him in the Sierras. He was a really critical earth scientist, so he was trying to understand why our planet changes. You may know that my son's middle name is Lyle or Lyell. He's named after Charles Lyell, the guy who invented, or rather coined, uniformitarianism, the idea that previous processes that shaped the planet before can still be observed today. This was one of his contemporaries. So he was trying to understand how we got our current planet. And so he built a science experiment. But back in the day, to make a science experiment, the first thing you had to do was build the plumbing, because there was no glassware. In 1858, they did have glass, but it was not really used for scientific experiments. I can just call somebody on the phone and these things show up at my house. But homeboy had to build everything himself. He even made his own copper tubing. Yeah. He made this really complex experiment, first of all, to build the gases that you find in our atmosphere, and second of all, to see what those gases do. I've kind of run out of steam, so to speak, but did I show you this experiment yesterday? You'll have to take my word for it. I'm sorry, I won't be able to demonstrate for you. Identical plastic bottles, identical rubber corks, equal volume of the same type of water. One of these had Alka-Seltzer added, the other one did not, then they got corked. Alka-Seltzer fizzles when it falls into water. Have you seen that? The bubbles are CO2. And so one of these had atmospheric air, the other one had atmospheric air enriched with CO2. You leave them both out in the sun on the sidewalk for a couple hours. By now the CO2 is left, so I can't show you the experiment. But you leave them outside, and then insert probe. And after you insert probe, you can measure the temperature in both of the bottles, and the one with CO2 will be about 2 degrees hotter than the one without. I can't do it anymore because I ran out of hours. But homeboy did that same experiment, and about 160 years ago.
How does this work?
Very well. You can still see it in France. This stuff was, I think, I don't know how it got to France because he's not French. I don't understand the mechanism, but throughout the experiment, something adds water vapor, something adds CO2, something adds sulfur, methane. He tries to replicate the makeup of our planet's atmosphere, and when you cut out the greenhouse gases, you don't gain as much heat.
So that's just a simplified version of that.
Yeah.
Could it just use 2 bottles?
Yeah. When my mother was 1 year old, this guy, his name is Charles Keeling or Keating, this guy published an opinion piece in the New York Times that says, you know, if we're all going to keep burning fossil fuels, that gives off CO2, which of course we all know is a greenhouse gas, we're going to warm our planet. This was considered to be like a fairly rudimentary observation. He was not like Stephen Hawking or something. It was kind of like some dude that was working on climate that was like, you know, just so that we all start thinking about this. So the government paid him to start measuring CO2. He, Charles Keeling, there we go. he went to Hawaii. Yeah, that little volcano that's so high in the air, 2,000 feet, middle of the Pacific. No factories nearby. All he's measuring is the